Hi everyone, and welcome to the flipped recording for 2.04 particle motion. So don't forget you will be submitting your science notebook at the end of the unit, so you want to make sure that you have notes and guiding questions answered, as well as any notebook activities that you might see in the lesson. So if you struggle with taking notes, listen for the parts of the lesson that I tell you to add to your notes page. I'll be covering the guiding questions as well, so be sure to jot down those answers as we go. And as we jump into the lesson, let's take a look at the introduction. So what happens to molecules of water when heat is added or removed? There are many ways to think about the effects of heat on a substance, from how it affects density to particle motion. In this lesson, you will develop a model to explore the cause and effect relationships between heat, temperature, density, particle motion, and states of matter. All right, so there's only two guiding questions in this lesson that we'll have to do. So I just like to take a screenshot of those and put it on a Word document over to the side so that I make sure we get through both of those. So I'm just pasting that over really quick. The first thing we're going to be looking for is what happens to liquid water when heat is added. So as we jump into the lesson portion, the Explore, so we're talking about particles, and you might remember some things about particles from semester A. Consider the question, what happens to liquid water when heat is added? And we just read that. That's our first guiding question. So there are many ways to answer this question, describing different aspects of the water. So some of your answers could include, maybe you want to put all three of these. The water's temperature increases, water molecules move around more easily, and the liquid becomes water vapor. So you can see as the water starts to boil, steam rises, that's the vapor. Can you think of any other responses? So we can also say that the water becomes less dense. Water molecules spread apart from one another. So that is the answer to guiding question 1. And the next one we're looking at, what happens to liquid water when heat is removed? So a similar exercise can be done to consider the effects of removing heat from the water. So how could you answer the question, what happens to liquid water as heat is removed? So we can almost think about that as the opposite reactions happening. So things that you could include would be the water's temperature is going to decrease. So now just think about going from water to ice. So the temperature decreases for that to happen. The molecules slow down. Water becomes denser, so we know that those particles go closer together as they form a solid when it reaches the freezing point, and then it becomes less dense. So the particles become less dense and water changes from a liquid to solid ice. So that is your answer to guiding question 2. So you know that the addition and removal of heat to a substance can have a variety of complex effects on a substance. When considering a complex problem, it helps to understand it by creating a model that represents the problem. One way to create a model is to break down a problem into steps. So we're going to gather the materials you will need to complete the next activity. And this is leading into your science notebook activity. So you probably want to take some notes here to start formulating some ideas to be able to design your experiment. So for the notebook activity, we're creating a model that represents the causes and effects of the addition or removal of thermal energy or heat within a substance. You'll create a flowchart that visually represents what happens to the following factors. So what happens to particle motion, temperature, density, and state of matter. So we just went through those examples with the water example in the lesson. So that would be something that you could use, and you're creating a diagram. So in your science notebook page, on your slides, or if you're handwriting it, I should see a diagram or flow chart with each of these steps. So it says, keep in mind in a flow chart, each step must directly lead to the next. Finding the correct order of steps is important in developing this kind of model. At the top of a blank piece of paper, write the title, Thermal Energy Cause and Effect Model. So this should be at the top. You can do this digitally in your science notebook right on the slide, or you can do it on notebook paper and take a picture, email it to yourself, and then copy paste it into your PowerPoint. So you'll do that. You have the title, and then follow the instructions on the next page to develop your model. All right, so it lists step by step what we need to do. So choose a substance to use as your representative for the model. This could be water, helium, oxygen gas, any other substance that you would like to use. Keep in mind you'll have to know enough about this substance, its melting point, boiling point, things like that. So water would be a very easy one to choose. So near the top of the page, write the following sentence. Heat is added to, and then insert your substance name, and include your substance in the sentence. Very easy. So that's right under your title. You're going to draw a short arrow from this sentence. So you may not put it right under the title. May start it over a little more to the left. Draw a short arrow down from this sentence and think about how the addition of heat would affect the movement of particles, and write a sentence or two describing this effect. So these are things that you would have gathered from the lessons before. We know that heat transfer goes from hot to cold. So any area of heat, it's going to heat is going to leave your substance and try to be at basically room temperature. So if you think about setting down a hot mug of something to drink, the heat leaves it, and it usually they go to an equilibrium, right, where your drink becomes room temperature. So think about drawing that arrow and how you would explain the addition of heat, how it affects the movement of the particles. Do they speed up? Do they slow down? And then next step would be to draw an arrow down from that sentence and answer, what effect does this have on the temperature of your substance? So does it boil? Does it melt? So think about that. Maybe you chose a solid. And then draw another arrow from that and write, what effect does the temperature have on the density of the substance? So think about that with the water. We know that as the temperature decreased, the density decreased. We read that in the lesson. And then for step 6, draw a final arrow, and you're going to write, what effect does the change in step 5 have on the state of matter? So did it melt? Did it boil? Did it bubble? So you're writing that. And then you'll review those steps that you've outlined and move on to the next page because you'll continue developing your model. Next it says, next to each step you've outlined, draw an illustration representing the molecules that make up the substance. Each illustration should accurately represent how the positions of these molecules reflect the changes you describe in each step. So here's some things to consider. How will you illustrate the movement of molecules? So most of the time, if you think back to lessons where we've had atoms, you'll just see little circles that are labeled. So for a water molecule, you would have an H and 2 oxygens touching to form the water molecule. Then would those molecules be packed tight together? Like if they're a solid, if it's frozen water, or would they be more spread out if it's a liquid, or would they be floating freely if it's a gas? So how would you describe that? How would you visually represent each molecule, especially if the molecules are highly complex and made of many different atoms? So for instance, water would be very easy, but like sugar, we know is a much more complex atomic formula. So how would you represent that? And then how will you illustrate any phase changes of the substance through the position of the molecules? So if it starts out an ice cube, you would have the tightly packed water molecules, and then as heat was added and the ice cube melted, those molecules would spread out to have like what molecules look like in a liquid where they're moving around each other. So they have more room. So you'll be drawing those out as well. All right, and then finally it says create a second model that represents the removal of heat from the substance. So we're choosing the same substance that we used before, or you could do another one, but it says water, butter, oxygen gas, anything that you can think of that you would like to use. Near the top of the page, you'll write heat is removed from your substance. And you can do this on the same page. Include your substance and name in the sentence. So we're just doing the same thing, but basically reversing it. Instead of adding heat, now we're removing it. So then you draw a short arrow down from this sentence and think about how the removal of heat would affect the movement of particles. So you write a sentence or two describing that. Then we're going to draw another arrow and explain what does the effect or what effect is the temperature of your substance? What is it? How did it affect it? Did it melt? What did it do? Draw another arrow from there. What effect does the temperature have on the density of the substance? And then finally, your last arrow you're drawing, what effect does the change in step 5 have on the state of matter? So now we're determining, did it melt? What did it do when we removed the heat? It wouldn't have melted it, maybe it froze. And then now you're going to do the same thing. You're going to illustrate your steps. So you'll go through and illustrate the movement of the molecules, represent each molecule again, make sure those are labeled so I can tell what it is. And then how you illustrate the phase change. So you want to make sure that you are showing if it is a heat added, if they're close together, or if they're spread far apart. All right, and that is the last page of the lesson. So once you move on with that, let's see if there's a quick review to wrap up. So if you're having some trouble understanding, you might look at this as well. The relationship between temperature, energy, and particle motion is very important. Answer the following questions to check your knowledge. How does the kinetic energy of molecules in an object change when the temperature increases? So the answer there is as the temperature of the molecules increase, the average kinetic energy of the molecules also increases. So that is the end of the lesson. Make sure that you get that notebook activity completed correctly and put into your science notebook. And then if you have questions or need help, make sure you come see me in Help Lab or come to a live session and we can talk about it. Have a great day.